Welcome, guys, to our second week of e-learning. Mr. Campbell is back here on a brand new Monday, kind of getting back off of our weekend, off of the end of our last week. I know a lot of you guys did an awesome job with your first week one unit quizzes. Again, it is pertinent that you guys have those notebooks up to date, that you're following along day by day in order for you to maximize your academic success on those quizzes and as well as our notebook checks, which are coming up soon. So let's first start off. As you can see here, I'm starting off right with the presentation. Again, trying to make my time shorter as we go along, keep it at a good 15-minute balance. We see here with the Unit 7 vocab due on Friday, we have our newest and latest weekly assignment. So go ahead and go to Edsby to check that out. I'm going to show that to you in a second. Our next notebook check submission will be this Friday as well. Again, we will not have any updates on Friday, as it is not a school day for us. It is a non-student day, but I will, because we all have access to our computers or e-learning, I will just keep, instead of having it all due on Thursday, I'm going to push it back to this Friday. So feel free to submit it no later than Friday for our notebook checks and our Unit 7 vocabs. But also we will have our next unit quiz. I will post that first thing on Thursday. So again, watch our short video lesson on that day, and then you will actually get to start your quiz for what we've gone over this past week on Thursday. Again, usually it may also include some stuff from the previous week on that Friday or Thursday as well. Okay, so let's go ahead and check out as you guys can see my screen hopefully here. Let's go ahead and check out the Edsby. Again, as you can see here, we've got our latest assignment. We have 15 vocab words listed here. Again, you guys know the kind of details on these. We've done these time and time again, every so often. Again, I just need you to define the terms in your own words, use them in an example sentence. Again, not the definition. This is separate from that, right? And then you will need to sketch an illustration, just a little doodle, nothing that takes too long, nothing too crazy with that. Again, that'll be worth actually now 20 points. And it'll be all about lunar stuff we'll learn about, some asteroid, solar system stuff as well. Again, big things we're going to get into with this next section of this unit is going to be the moon and the moon's behavior and its relation to the Earth as well. Again, don't forget to be taking your daily attendance poll tally as we get that going. Okay, but let's get back and get started with our Go Blue here. It's got 3 things I want to discuss today. Oh, I think I said, I'm trying to access this here. The button up here is in the way. That is really frustrating. Oh, here we go. So all I gotta do is move the button. Okay, so I moved the button here. I don't think you guys can see the button. The button at the top of my screen, I've got all these like different buttons that help me like change the settings of my my videos that I'm recording on Zoom. Okay, question number 1. The sun converts blank into blank. What elements is it converting into? 2, what planet poles on the asteroid belt? 3, inner planets are blank with blank melting points. And 4, why are the inner planets smaller than the outer planets? Again, these are topics we kind of touched on, but some details we didn't touch on as much last week. So some of this stuff was actually introduced on the review day. If we were in regular class right now, we would actually be taking our Unit 7 test. I got 2 tests for Unit 7 because Unit 7 is a big unit. And we would have done review day. I would have discussed it also, the writing questions, things like that. So I'm just going to include this in the Go Blue, and we will go ahead and discuss it together. Okay, so number 1, the sun is going to expand over time. Again, it's got many billions of years left in its lifespan, so no need to worry too much there. And we all know the 2 elements are going to be hydrogen and helium. So it's going to be converting hydrogen and then burning it up with nuclear fusion into helium. Again, it's mostly hydrogen, but it is going to be converting that, as I said, into helium. Number 2 for our Go Blue answers. Again, this is kind of from our recent test that we would have taken. As you guys know, with us not being able to take labs together, to do the review game days together we did in class, the group test analysis in class, and the general, just the day of the unit test. All those are gone, so we have reserved those for just our quiz days and our assessment days at the end of every week. Jupiter's gravity, number 2, pulls and creates the asteroid belt. So the planet that is very involved with pulling the asteroid belt. Again, keep in mind, the asteroid belt is kind of like the barrier that separates the rocky planets, terrestrial planets, from the larger gas planets. So it's this barrier, right? And what happened is all the planets that were inside the asteroid belt, all the asteroids and all the gases that were there, they did eventually get oh, well, that's going to be for another question, actually question number 4. But for number 2, yeah, the asteroid belt separates gas planets and rocky planets, and the planet that controls the gravity of that asteroid belt is going to be Jupiter, because as we know, it is the largest planet in our solar system. Okay, so again, Jupiter is going to be the main force there, and then Mars, kind of small, much smaller, obviously, and the other side is also between Mars and Jupiter. Okay, number 3. Inner planets are rocky, also known as terrestrial, with high melting points. Keep this in mind, guys. If they had low melting points, they wouldn't even survive because they're so close to the sun, right? So low melting points means they melt easily. High melting points means they're strong, they're tough, they're able to withstand the solar radiation very easily and stay put. So rocky, solid, high melting points. And then number 4 asked us about why are there no materials or not as many asteroids or moons with the inner planets. It is because most of the smaller materials near the inner planets, because they're so close to the sun, they got vaporized by the sun as the solar system was forming. As I've said time and time again, the solar system is like the different layers of oils in the cylinder that we've seen those videos of before, right? So the planets are all a different type of density and kind of different materials that kind of individualized from the gravity as well as the sun's energy. So again, most material got vaporized, including all those potential suns that we could have had that the outer planets have much more of. All right, lastly, all of space components are brought together by gravitational force. Gravity is the greatest force in space, as we all know. Again, these are just Go Blue answers, so make sure you've written those down, what's in yellow on page 2. Yes, ooh, you guys might get a little confused here. Okay, we are starting a new unit because, like I said before, it's the same unit, but it's in 2 parts. Like I said before, Unit 7 is a very lengthy unit, and I did have a test after what we just finished. So because we can't take physically tests, and I can't put 30 to 40 question test on EDSB, I can only get up to like 15 to 20 questions. I'm going to split this up a little bit. So go ahead on your notebook for part 2 of Unit 7, add page 1, which is this table of contents, and then pages 2 through 3, which are going to be planet discovery and spacecrafts. Okay, so let's go ahead and do our first practice question today. Again, I hope you guys notice I'm going a little faster for you guys now. What is the correct order of gas planets from closest to the sun to the farthest from the sun? Okay, so keep in mind that planet order, right? Is it going to be A, Jupiter, Saturn, Neptune, and Uranus, B, Neptune, Uranus, Saturn, and Jupiter, C, Jupiter, Saturn, Uranus, and Neptune, or D, Uranus, Neptune, Saturn, and Jupiter? Pause the video, think about it. Again, as I go along here, always make sure to pause as we go, because you will need me to pause, obviously. Okay, and our answer to this question is going to be, it's going to be C, guys. Jupiter, Saturn, Uranus, and Neptune. That is the order, and that does not actually include Pluto. So let's get into that. Why is Pluto no longer a planet? What is the deal? What is going on? I want you to write these 2 questions down on page 2, because I know if we were in class today, you guys would love talking about Pluto. I got a lot of people who defend Pluto, who are very passionate about Pluto as a planet. I grew up as well, all through elementary, middle school, and I believe most of high school, maybe. I can't recall what year Pluto was no longer considered a planet. It was fairly recently, just going back within the past decade, at least I'm thinking. But number 1, why is Pluto not considered a planet? What about it makes it not a planet? And 2, how are planets and dwarf planets similar? You guys, and dwarf planets, that is one of your vocab terms, okay? What makes Pluto a dwarf planet and not a planet, right? But how are they similar? Okay, so go ahead, and no need to worry about what's in red. Again, you're going to learn about this the day of our review game. you guys will watch these two video clips, very interesting, that detail and explain Pluto's story. I'm just going to show you a snippet of one. The first one is of the science show. Really good stuff there. Kind of gets into entertaining details with that. Second one is Neil deGrasse Tyson, who kind of details some of the reasons why Pluto is not a planet, but certainly a planet, a dwarf planet, I should say, that we should not forget about. So let's go ahead. These will be posted to Edsby. As you guys know, I can't show the whole videos like I would in class, but I will show a little snippet here of Neil deGrasse Tyson giving us some details, explaining a little bit why Pluto.
Pluto had it coming. Pluto is small. It's smaller than Earth's moon. That Earth's moon is 5 times the mass of Pluto. Did you know that? I don't think so. Another measure of how small it is, if Neptune were a Chevy Impala, and you can ask, what size car would Pluto be? Might it be a Prius? Nope, smaller than that. How about a Mini Cooper? Smaller than that. Would it be about the size of a smart car? Good guess, but still wrong. You know how big Pluto would be if Neptune were the size of a Chevy Impala? It'd be the size of a Matchbox car sitting on the curb. This is not a Matchbox. I don't have one. I don't even have. It'd be about this size.
So big idea that he's explaining is the size of Pluto. Very tiny, extremely small. And another thing he might mention a little bit is about Pluto's movement, Pluto's orbit as well. So keep those things in mind as you watch those videos and get those details on your own. Okay, let's move on to one last thing I'd like to mention and discuss. That is going to be some thought questions, okay? Things to think about a little bit are, how do we know there are other planets and solar systems out there, right? How are we able to see those other planets in space? Again, no need to write these questions down. They are not in yellow. Let me see what our other question was. 3, do you think there are other Earth-like planets out there, or are we alone? And then 4, what is a space observatory? All questions I would have loved to discuss together in class. Okay, so things we're all going to know about here in the coming days of our unit. Well, last thing I want you to write for the day, guys, on page 2 or 3. 2 was the Go Blue, guys. Page 3 is the next page if you needed more room with all the video stuff and all the Go Blue stuff we wrote down. We need to know about the Hubble Space Telescope. I'm sure you've heard quite a bit about this telescope. Okay, it was launched in 1990, so only about, I would say, actually 30 years old, right? One of the most incredible tools that scientists and astronomers have used to date to see much of space, in fact, deep space, okay? So it's massive, say the size, massive telescope that launched in space and basically magnifies, using tons and tons of lenses, the deep nebulas, deep stars, and potentially observing areas of other solar systems. So the things we're going to use for this include infrared and ultraviolet wavelengths to record visible light images. So I've actually got some video questions I'm going to show you guys tomorrow that get into detail the specific pictures and videos that have been recorded by the Hubble Space Telescope, as well as its history. So it's going to be observing the most it's going to be basically recording the most high definition images of planets, of other solar systems and galaxies that we've gotten to date. So think of it as like, I don't know, what's the best camera company? Is it maybe Kodak or Nikon? Think of it like one of those, the best, best cameras that you can use, but instead use for space. Okay, so we were able to see kind of up to that point blurry images of other planets, blurry images of galaxies. This allowed us to see very detailed images of those galaxies, right? Incredible stuff. So I'm going to show you guys, actually, let's go ahead. I did want to show you a quick, like 30-second clip here of kind of a 3D image of the kind of design of the Hubble Space Telescope. Really beautiful, incredible stuff here.
Very high.
Okay, so we see here again this metallic structures, and within that we've got we see obviously our wings there, which are used for solar energy. Okay, absorbing it so that again it can stay functioning in space, and a little balance beam at the bottom there, and then within that are the multi-lenses that are going to be used to actually magnify those images at a greater rate. So I'm going to show you, have you watch videos tomorrow in much more depth another day, right? So let's look here. We saw the 3D design there. Okay, let's finish up with our last activity of the day with the last question I want to show you guys. All about planet order again. Let's see here. So now we talked about the gas planets earlier. Now let's get into the rocky planets. What is the correct order of terrestrial planets from farthest to the sun now to closest to the sun? So farthest to closest. Is it A, Mercury, Venus, Earth, and Mars, B, Mars, Earth, Venus, and Mercury, C, Mercury, Venus, Earth, Mars, and Earth, or D, Earth, Mars, Venus, and Mercury? The correct answer is going to be, guys, B, Mars, Earth, Venus, and Mercury. People oftentimes get Mars mixed up with Earth in order because, oh, it's red, it's like dry and barren, it's got to be closer to the sun, right? It looks more like a desert, it looks hotter than the Earth. And they call it the red planet, right? Think it's going to be hotter. Red associated with hot a lot. Okay, that is indeed false. Okay, Mars is farther from the sun than Earth is. Reason why Mars is a desert, we are not, is because we have a magnetic shield around our planet that gives us an atmosphere and protects us from solar wind flares. Mars does not have that magnetic shield, which exposes it to those radioactive rays and solar wind, which makes it all dry. So guys, again, go ahead and work on that vocab assignment. Stay on track with your notebook, as we will have a notebook check here in a few days. Keep up the good work, guys. And other than that, if you have any questions, let me know. Mr. Campbell signing out. Everybody have an awesome day. Have an awesome Monday, and keep up the good work.